Assalamualaikum and hi to everyone. So today, our group have been assigned to do a video assignment about application of differentiation. But before that, let me introduce you to our team member. The first member is Muhammad Faiz Fahmi bin Zuhaimi, Muhammad Shukuri bin Razali, and then Nurin Afifi Adira bin Rizam, and the last one is Ahmad Adam Aiman bin Samsul Bahari. We are from class J4 CEEM 1101F. As for the introduction, I will explain to you guys what is differentiation. Differentiation is a process of finding the derivative or rate of change of a function. This is to determine the maximum and the minimum values of particular functions. And what is differentiation rules? Differentiation rules conclude sum of difference rules, product rules, quotient rules, and chain rules. Differentiation have few types of application. As shown, there are related rates, analysis function 1, analysis of function 2, Rolle's theorem and mean value theorem, and the last one is applied maximum and minimum problems.
Objectives: to calculate the rate of change of quantity, to find critical points, to determine where a function reaches its maximum or minimum values, use derivative of a function to achieve the slope of the tangent line at any point of the graph, to solve problems of the rate of change of two or more variables that are related.
Analysis of function 2 includes relative maxima and minima, critical points, first and second derivative test, graph of polynomial function, graph of rational function. Next, the problem statement for analysis of function 2. Consider the function fx is equals to 1 over 3 x power of 3 minus 1 over 2 x power of 2 minus 2x plus 4. First, find the y-intercept of fx. Second, find the critical points of fx. Third, find the intervals where the function is increasing or decreasing. Hence, determine the relative extremum of fx. Fourth, find the intervals where fx is concave up or concave down. Hence, determine the inflection point of fx. Fifth, sketch the graph of fx using the above information.
Description of solution example number 1. Question number 1. Find the y-intercept s equal to 0. Then change the s value with 0. Function 0 equal to 1 over 3 multiplied with 0 power of 2 minus 1 over 2 multiplied with 0 power of 2 minus 2 multiplied with 0 plus 4. Our answer is 4. S-intercept y equal to 0. Then fs equal to y. Our answer is fs equal to 0. Question number 2. First, we need to differentiate the function. So, our function fs will become f prime. F prime equals to 1 over 3 x power of 3 minus 1 multiplied 3 minus 1 over 2x power of 2 minus 1 multiply 2 minus 2x power of 1 minus 1 multiply with 1 plus 0 equals to 3 over 3x power of 2 minus 2 over 2x minus 2. Then x power of 2 minus x minus 2 equal to 0. Then use calculator. We will get x equal to 2 and s equal to minus 1. So that our critical value. Then we can find our critical point by using the critical value in the coordinate xy. First coordinate is 2y. Change the s value with 2. Then the equation is y equal to 1 over 3 multiply 2 power of 3 minus 1 over 2 multiply with 2 power of 2 minus 2 multiply with 2 plus 4. Y equal to 2 over 3. Then repeat the same method with the second coordinate, which is negative 1 y. Change the s value with negative 1, so our equation will become y equal to 1 over 3 multiply with negative 1 power of 3 minus 1 over 2 multiply with negative 1 power of 2 minus 2 multiply with negative 1 plus 4. Y equal to 31 over 6. So our critical point is 2 over 3 and another one is negative 1, 31, 6.
The third question is how to find the interval where the function is increasing or decreasing. Hence, determine the relative extremum of fx. First, give to the three column. First column, put the value from negative 1 and negative infinity. The second column, negative 1 to 2, and the last column, 2 and infinity. For the second line, put the value. For the first column, the value must not more than negative 1. For the second column, around negative 1 and 2, and for the last column starting from 2 and above. After that, put the value in f prime x equation. For the first column will show a positive value, so the function is increasing. For the second column will show a negative value, so the function is decreasing, and the last column will show a positive value, so the function is increasing. The next question is how to find the interval where fx is concave up or concave down. Hence, determine the inflection point of fx. First, find the value of x from f double prime x equation. After that, give to two column. The value for the first column is must not above 1 over 2 and the second column must around 1 over 2 and above. The second line, put the value. For the first column, the value must not more than 1 over 2 and the second column must more than 1 over 2. After that, put the value into f double prime x equation. First column will show a negative value, so the value is concave down. The second column will show a positive value, so the value is concave up. How to find inflection point of fx? Use x equal to 1 over 2 value. After that, put the value of x into the function fx equation. For the last question is sketch the graph of fx using the above information. The maximum and minimum point is from critical point, and the point between maximum and minimum point is from inflection point. For the graph sketch is from the conclusion of question number 3.
Conclusion. At the end of this lesson, students managed to calculate the rate of change of quantity, to find critical points, to determine where a function reaches its maximum or minimum values, use derivative of a function to achieve the slope of the tangent line at any point at the graph, to solve problems of the rate of change of two or more variables that are related.
And that's all from us. Thank you for watching.